Okay, in this problem, we are trying to maximize right here daily revenue. Now we know that a 230 room hotel is filled when the room rate is $50 per day. Then for each $3 increase in rate, 3 fewer rooms are rented. So if they charge too much, nobody will rent, right? But if they charge too little, then they won't make any money because they're not charging enough. So there's some sort of middle ground is the idea where you charge enough so that you can maximize, often actually you're trying to maximize profit, but in this problem we're just trying to maximize revenue, which is a tad bit easier. So I'm going to flip over to the textbook. So this is 3.3 example 3. It is quite a bit like this problem, so I'm going to follow this one as the breakdown and use the same variables, because I'm assuming that's what most of you have done. So what we're going to do is let R be the number of reductions in price. So in this problem, the example problem, Sally sells 20 hard drives a week at $400 each, and for each $10 reduction in price, she estimates that she can sell 2 more drives per week. Of course, that's an estimation, but we're going to go with it. So we're going to let R be the number of reductions in price. In this problem, that's what they did. So in our problem, it's actually the opposite. For each $3 increase in rate, 3 fewer rooms are rented. So let's go ahead and I'll put it right up here, let's let R, lowercase r, lowercase, be the number of $3 increases. We're just assuming that all increases will be in increments of $3. Okay, now let's flip back to the textbook. So they let lowercase p be the price of each hard drive after a reduction. And then they really didn't actually use that. There was a problem, but that's the price right there. So lowercase p is the price of each. In our case, that would be the price of each room after an increase. What we're trying to do is find the room rate that maximizes daily revenue. So let's go ahead and think about, what does revenue mean? Like, just generally, how do you compute revenue? Typically in this class we let revenue be capital R. Often it's R of X. In this case let's use R of N, because that's what they do right here. Lowercase n is the number of hard drives produced and sold. So in our case, let's come up here and let N equal the number of rooms rented. The revenue is a function of the number of rooms that are rented. And so just generally, if you're the hotel owner, the revenue you bring in is the number of rooms that you rent times the price that you rent them at. So I'm going to write that down. It's the number of rooms that are being rented times their price. Okay, what we want to do is put each of these in terms of N, and then we'll differentiate it and find what has a max. So the number of rooms being rented, that is right here, lowercase n. So that's N times the price. It is writing all over. Okay, so what is the price of each room? That's the slightly more challenging part. So we're assuming we're starting at $50 per day. And then R is the number of $3 increases from $50. So the price of the room is 50 plus $3 for each increase in price. Now we have to figure out how to get that in terms of N. So let's follow this example down here. So since revenue R in this one, they did the price is 400 minus 10N because they were talking about reductions in price, which is why there's a minus instead of a plus like we have, times N, the number sold, that's what we have as well. So it says the expression R comes from the fact that the sales price is 400 minus $10 for every reduction, but also the number of drives sold, N, is 20 plus 2 times the number of $10 price reduction. So that's how they figured out how to they actually got N in terms of R in this case. So that comes from the estimation at the beginning. So let me read this again. It says the number of drives sold is 20 plus 2 times the number of $10 price reductions. Right, that's because for every, right here. So it's starting at 20 drives. They're currently selling 20. And then for every $10 reduction in price, she sells 2 more drives per week. So that's why it's 20 plus 2R. The number of drives sold is 20 plus 2R. So in our problem, we want to put this in terms of R. The number of rooms that are being rented, well, let's start with 230, because that's what's currently happening. Then with each $3 increase in the rate, 3 fewer rooms are rented. So we're going to go minus 3R, because that will take off 3 rooms. That's that 3, and that 3 correspond. So for each increase in the rate, that's R times 3, because that's how many fewer rooms are being rented with each increase in rate. And we have that multiplied right there. So, and also this side, I'm going to go ahead and write N equals 230 minus 3R. Actually, I put N there, but let's just go ahead and call it capital R of little r, since that's what we've got here. I would go ahead and simplify this before differentiating. So R of R would be 230 times 50 is 11,500. I'm just foiling here. Then 230 times positive 3 is 690, so we'll have plus 690 R. Then that's going to be minus 150 R. My last term will be minus 9R squared. Combining these middle terms then, capital R of R. And I'm going to reorder the terms, because usually we have the square term first. It's negative 9R squared, then 690 minus 150 is 540 plus the constant 11,500. Okay, and I need to make some more room here. That looks easy to differentiate, so let's go ahead and put capital R prime. It's negative 18R minus 540. It'll be pretty easy to find where that has a math. So negative 18R equals 540. So 540 divided by 18 is exactly 30, and actually it's negative 30. So if lowercase r is negative 30, and r is the number of $3 increases in price, this is suggesting that we should have 30 decreases in price. Now that really doesn't make sense to have 30 decreases in pricing, as the price started at $50 a day, and if we decrease it by $3 30 times, then we'd be charging negative $40 a room. So looking back at my work, my setup all makes sense, but what I did right here is I said that 690 minus 150 is negative 540, and that should have been a positive 540. So let's fix that. Positive 540, positive 540. Then that would be negative, so this would be positive 30. Now that makes sense. So we should have 30 $3 increases in price is what that's saying. So that means the price should be, that means we should increase the price by $90. If we add $90 onto $50, then we should charge $1 $140 per day.